Hey there, folks. For this final episode of Geology Basics, we're going to cover rock types and the rock cycle. Rocks come in three forms: sedimentary, igneous, and metamorphic. First up is sedimentary rock. As the name implies, sedimentary rocks are made of sediments cemented together to form rocks. Some common sedimentary rocks are sandstone, shale, and limestone. Sandstone is made up of grains of sand, mostly quartz, cemented together. Typically, the cement is made of silica or calcite, but can be made of numerous other minerals. Shale is made of grains of clay compressed together. These grains have no real cementation, resulting in an extremely fragile rock. Shale is highly porous but is impermeable, meaning there's a lot of open space between the grains, but these flat layers of clay grains don't allow fluid to pass through. Limestone is composed of minuscule grains of calcite, usually the remains of microscopic organisms. It's possible that the calcite can dissolve in water, react with minerals in the water, reform as dolomite, and then turn the limestone into dolostone. Next up, we have igneous rock. Igneous rocks are formed from the cooling of lava or magma. They come in two forms: plutonic rocks, which form underground from cooling magma, and volcanic rocks, which form above ground from cooling lava. Plutonic rocks tend to have larger crystal grains as they cool slowly underground, while volcanic rocks have smaller crystals from cooling rapidly on the surface. For an example of both, we have granite and basalt. Granite is a plutonic felsic igneous rock. Felsic means it has a high silica content. So granite has large grains on account of being a plutonic rock and a high silica content. Basalt, on the other hand, is a volcanic mafic rock. Mafic means it's low in silica and high in heavy metals like iron and magnesium. So basalt has small grains, as it is a volcanic rock, and a higher heavy metal content. Lastly, we have metamorphic rock. Metamorphic rock begins its life as either igneous or sedimentary rock, or sometimes other metamorphic rocks, before being buried and exposed to extremely high heat and pressure. This process alters it into metamorphic rock. A couple examples are quartzite and gneiss. Quartzite begins as quartz sandstone or chert before becoming compressed and heated. This process fuses quartz grains together to form an extremely tough rock. Gneiss, aside from being the source of endless geology puns, is considered a high-grade metamorphic rock. This is because it required a higher level of heat and pressure, or high-grade metamorphism, to form than other metamorphic rocks would. Gneiss begins as an igneous rock or lower-grade metamorphic rock before the intense heat and pressure transform it. Now, much like water, rocks also have a cycle they go through in nature. However, unlike the water cycle, the rock cycle is incredibly slow. So slow, in fact, that it hasn't actually completed a full cycle in the entire history of Earth. All rock on Earth began as molten rock. This molten rock then cooled to form igneous rocks. Then there was a few ways things went. Some rock weathers and it becomes sediment. Other rock remelts into molten rock. And other rock gets buried and exposed to intense heat and pressure to become metamorphic rock. The sediment then cements into sedimentary rock, where it could go down those same three pathways as the igneous rock. And then the metamorphic rock, you guessed it, goes down those same three paths. So over the course of geologic time, rocks go through this cycle, transforming into other types of rock, becoming recycled. And that concludes our last episode on the basics of geology. I hope you enjoyed this series. Next week I'm going to get started with some of the basics of paleontology. If you liked the video, please leave a like and consider subscribing. I really do appreciate it. And if you'd like to suggest a topic for a future episode, leave a comment. Till next time.